Hi, I'm Greg Pollock, and in this video, we'll be looking at why the Composition API was created for Vue 3. We'll start by taking a look at the limitations of Vue 2, and then look at how Vue 3 solves these problems for us. There are three limitations you may run into when using Vue 2 to create components. The first is as your components grow and get bigger and uglier, they become less readable and therefore less maintainable. The second is that as you reuse pieces of code across components, each of these code reuse patterns in Vue 2 has its drawbacks. The third is that Vue 2 has limited TypeScript support. There's ways to write it with TypeScript, but they're not completely optimal. Let's dive into the first limitation, which is that large components may be hard to read and maintain. Let's imagine we're creating a simple search component. You know, a search bar that looks like this. Using the regular component syntax, we would create a .vue file, which might have a data option with reactive properties, and our methods for our search logic. Once complete, we realize we need some sorting functionality. So we write up the code, which also has some reactive properties and some methods. Our code for each feature, as you can see, is split up between two options. Things aren't too messy, but they would be if we added additional functionality for, say, search filters and pagination. The problem here is that logical concerns, or features, are organized by component options. And there's a lot of component options in Vue, things like components, props, data, computed, methods, and lifecycle. Our feature code might be divided up into 6 different places. And if you think about a more complex component, having our code split up in multiple places just isn't as nice as having it all organized together, which makes our component more readable and maintainable. Even in our simple example, it'd be nice if our search code and our sort code was kept together, and Vue 3 makes this possible. Using the Composition API, we can keep our components more readable. This all starts with the new setup method inside of our components. Inside the new setup function is where we can start using the Composition API syntax. And this syntax is completely optional. We can still continue to code up components like we have before, using the regular syntax. I knew when I first saw this, I was saying, wait, does this mean I create a gigantic setup method with a ton of code? And the answer here is no. With Vue 3, you end up writing composition functions. These are outside of your setup method, and they could be in the same component file. Here you can see I have a useSearch function and a useSorting function. These are called composition functions, and they're called from inside the setup method, as you see here. Don't worry, we'll dive into the details of the syntax later. For now, just know that our code using composition functions can now be organized by logical concerns. I want to point out that this doesn't mean our user interface has less components. I'm not going to be writing each piece of my page in different composition functions. I'm still going to have multiple components for each part of my user interface. The second limitation of Vue 2 is that there's no perfect way to reuse code across components. And let me show you exactly what I mean. Back in our search component, there are 3 ways we could extract this code for reuse using Vue 2. The first is mixins. With mixins, first we would separate our code, then we'd create a product search mixin, create a result sort mixin, and then include the mixins in our component. I'll shrink this down for simplicity. The good part about this is now our code is organized by feature. However, with mixins, you can end up with property name conflicts. It's not clear if and how these mixins interact, and we can't easily reuse this code to search and sort different things, like maybe if we had a list of reviews or sellers or shipping options. The second solution we might use with Vue 2 is by creating a mixin factory. These are functions that return a customized version of a mixin. Here you can see we have our search mixin factory, and then we have our sorting mixin factory. Then inside of our component, we import these two. Then we use each of these mixins, specifying a namespace and any configuration we need for each of the factories so that it can sort products. Now, the generic parts of search and sorting can be reused. We also have clear relationships of how our features interact. However, namespacing requires strong conventions and discipline to do right. We still have to look inside each mixin to see what properties it exposes, and mixin factories can't be dynamically generated. Another solution that solves some of these problems in Vue 2 are scoped slots. What might that look like? We'll start out with a generic search component. This has props and it has a slot. We'll also have a generic sorting component, which has props for configuration and a slot. Then inside of our search component, we use these components, sending in configuration specific to product search. This addresses just about every downside of mixins. However, it does increase indentation, which decreases readability. Some of our configuration ends up in the template, which ideally should just contain what we want to render. Exposed properties like product search are only available in the template, and having 3 instead of 1 component instance means it's less performant. And those are the 3 ways you could reuse code with Vue 2. However, in Vue 3, we now have composition functions, a 4th way to reuse code. Like before, we have a file for our search functionality and a file for our sorting functionality. These each contain composition functions, which have a new syntax we'll get into in later lessons. Then inside of our search component, we include these composition functions and use them inside of our setup method, sending in any configuration they need. This solution uses less code. It also builds on your existing JavaScript skills since you're already familiar with functions. It's much more flexible than mixins and scope slots. Since they're just functions, IntelliSense autocomplete and typings likely already work in your code editor. The only downside here is that with Vue 3 now there are 2 different syntaxes for defining components, the regular syntax and this advanced composition API. Should I be cheesy? In the previous video, we looked at why the composition API was created. Here, we're going to review when to use the composition API and learn about the setup method and reactive references. I want to emphasize that the composition API is just additive. It's a second way to write components. All the previous component syntax that you're familiar with in Vue 2, you can still use. It's completely valid. The composition API is just a more advanced optional syntax. If that's the case, then when should you use it? So here we have a component, and I might use the composition API if I really care about good TypeScript support. I also might use the API if I have a huge component and I want to organize it by feature. I also might use it if I have code that needs to be reused across multiple components. And lastly, if I'm simply working with a team that prefers this syntax over the regular syntax, that might be a good enough reason too. The code I'm about to show you is quite simple, and you might be wondering, why would I use the composition API in this case? And you might be right. My goal here was to make it as easy to learn as possible. Let's take a look at a component using the regular syntax. Here we're printing out the capacity of an event, and capacity is in the data option, making it reactive. In our browser, we see capacity 3. How would we write this using the composition API? Well, first we need to create that setup method. The setup method executes before components, props, data, methods, computer properties, and lifecycle methods. It also does not have access to this, so our code inside here is going to look different. The setup method also has 2 optional arguments. The first is props, which is reactive and can be watched. So let me show you what that might look like. Here you can see I have a prop, which is name, and then I declare setup with the props argument. If I wanted to watch this prop for changes, I could import watch from view, then I could log out to the console whenever it changes. The optional second argument for setup is context. We use context to access properties that we'd previously accessed with this. Here are the different properties that it gives us access to. Now back to our example. Here we need to import ref from view and then declare capacity as a constant, which equals ref3. The ref function creates a reactive reference. This wraps our primitive in an object, allowing us to track changes. Previously, we were using data, and data was wrapping our primitives in an object for us. Now we're creating a reactive reference, which is an object that wraps our primitive, which in this case is 3. As a side note, with the composition API and the way Vue3 does reactivity, we can now declare reactive objects that aren't associated with the component, which is quite powerful. Lastly, our setup method needs to return anything that needs to get accessed from the template. So in this case, it's capacity. You might initially think this is more verbose, but it also makes our component more maintainable, since we can control what gets exposed in our template, and we can more easily trace where a property is defined. In our browser, everything is working. It's worth mentioning that this composition API syntax you can use in a Vue 2 app by using this plugin for Vue 2. You'll want to follow the installation options on the GitHub page, and then instead of importing from Vue, you instead import from Vue/composition API. This is how I tested all the code I'm showing you. Here's our code with our reactive reference inside of setup. The problem now is, how do we add a method? In our regular component syntax, if we wanted to increase capacity, we might create a method that looks like this. But what might this look like using our new syntax? Well, first, inside of a template, let's add a button that calls this method. Simple enough. To create a method using our new syntax, we declare a normal function inside of our setup method. We then need to return it from our setup method, which gives our template access to it. But what goes inside of our increased capacity function? Your first guess might be capacity plus plus. However, this is not going to work. It's going to error out because we can't increment an object. Remember, this is a reactive reference and not a primitive. If we inspected capacity in the console, we would see that it's a reference with a getter and a setter, and it also has this value property, which is what we need to access. So to increment capacity, we call capacity.value++. This is how we access the value on a reactive reference. Now if we jump in our browser, we can see that our button increases capacity. At this point I was wondering, and you might be too, why don't we need to call .value in the template when we print out capacity? Well, it turns out that when Vue finds a ref in the template, it will automatically expose the inner value. So you should never need to call .value inside the template. Back inside our component, we're going to add a list of the people who are attending our event. Here in the setup method, we're going to add an attending array, which is a reactive reference. We'll give our template access to it. And then we'll print a list of those who are attending. Our component now looks something like this. In addition to printing out our capacity, we now want to show our users how many spaces are left in our event. So in order to calculate this, using our regular component syntax, we might create a computer property which takes the current capacity subtracted by the length of our attending array. How might we do this using the composition API syntax? I'll shorten our template to make some room, and now inside of our setup method, first we need to import the computed function. Then we'll create a new constant called spacesleft, which sends into the computed function an anonymous function which returns the result of taking capacity and subtracting the number of people who are attending. Notice I have to use .value here since I'm dealing with two reactive references. I'll then give the template access to this computer property. If I jump in the browser, I can see that everything is working with my computed property like I'd expect. Up until now, we've been using reactive references to declare all of our reactive properties. However, the composition syntax comes with another equally valid way to declare reactive properties, which I want to show you now. To use it instead of reactive references, first we need to import reactive, then we'll create an event constant and call the reactive function, which returns a reactive object. We'll send in an object with each of the properties that we want to be reactive. And notice here it even contains our computer property. This might feel a little more familiar since we're used to declaring a reactive object using our data option. All we're doing here is taking our reactive references and instead declaring them in an object. You should notice that inside of our computer property, we no longer have to use .value since our object is taking care of reactivity. Then we'll declare a method. Again, we don't have to use .value. We can just say event.capacity++. And lastly, notice I can send the entire event object into the template. Both of these are completely valid syntaxes. It's up to you which one you use. Now, since we're sending the entire event object into the template, our template is going to look a little different. Notice here we have to specify event.event.event to access the properties on this reactive object. When I saw this code, I kind of didn't like it. Like, I wanted to be able to destructure that event object into pieces so that in my template I didn't have to say event.event.event. So I really wondered if I could destructure this event object so my template didn't have to have event dot in it. Now that I've changed my template, it wouldn't currently work. To make this work, I would have to change how I'm returning the event. My first guess was just to use ... However, that didn't work. My second guess was simply to list out each of the properties, but that also errored out. The problem here is that splitting apart the event object is going to remove its reactivity, so it's not going to work. The solution here is to take our reactive object and split each object up into its own reactive references. Luckily, Vue 3 comes with a function called toRef. So I'll import it, and then if I send event into this function, it's going to convert my reactive object into a plain object, with each property being a reactive reference that points to the property on the original object. I do want to mention though that if I didn't need to expose increased capacity to my template, I could instead simply write toRefs event. And I wouldn't need to destructure it since it's simply returning a plain object, which is what our setup function is expected to return. Aside from improved TypeScript support, the two reasons we want to use the composition API are to organize things by feature and to make the code reusable across other components. And right now our sample code does neither. So let's refactor as if we wanted to make things more modular. Here's our current code. This is nothing new based on what we've built. However, I'm now using refs because honestly, I think it's a little simpler. To organize the code by feature, I would move the code out of the setup method, create a new function called useEventSpace, which is our composition function, and then call this composition function from our setup method. Now our component is organized by feature, and if there was additional features I wanted to add, I could just start writing another composition function. But what if I wanted to make this code reusable across other components? To do this, I would move my composition function into another file. Let's put it in the use directory and call it eventspace.js. I'll then export this function and then import it into our component. That's all there is to it. What if I wanted to add another composition function inside this component called event mapping to map out the location of the event? Well, I would just import it, and then inside the setup function, you might think that I would just call both functions, but actually this isn't valid JavaScript. We can't create objects like this. Instead, I would destructure the object that each of these return, giving my template access to everything it needs to render. Our solution is pretty efficient, but by coding this way, we've introduced a problem. It's not clear by looking at this file which objects are being injected by which composition function. This was one of the problems we previously had with mixins. To solve this, we can create local objects for the data that our composition functions are sending in, and then use those in the return object. Now it's explicit which objects are coming from which composition function, and this is a Vue 3 best practice. You're probably already familiar with the view lifecycle methods like before create, created, before mount, mounted, before update, updated, before destroy, and destroyed. If you're not familiar with these, pause the video, read the descriptions. Moving on. There's some additional Vue 2 lifecycle methods which were released in recent versions I want to make sure you're familiar with. The first is activated. This is used when you have dynamic components using keep alive when the component inside keep alive is toggled on. Then there's deactivated when the component inside keep alive is toggled off. And error captured. This is called when an error from any descending component is captured. If you want to learn more about how these work, check out the documentation. But let's now dive into changes with Vue 3. First off, the before destroy lifecycle method can also be written as before onMount. Both should work. Also destroyed, you can also use unmounted. These should both work with Vue 3, and when I asked Evan Yu why this change, it's pretty much because it's a better naming convention. We mount a component and we unmount components. When we're using the composition API and we need lifecycle methods, we simply add on to the callback name inside the setup method. So here's what that might look like for before mount and on mounted. We need to import them, and then we can simply use them, sending in anonymous functions inside of our setup method. Here's a list of all the different lifecycle methods we can use inside the setup method. If you're being observant, you might notice that two are missing. Before create and created are not needed when we're using the composition API and we have that setup method. This is because before create is called right before setup, and then created is called right after setup. So code that would normally be put inside of these hooks should now be placed inside of our setup method. A good example here would be API calls. Typically we put those inside of before create or created, and instead we can call them from our setup method. There are two new Vue 3 lifecycle methods, the first of which is onRenderedTracked. This is called when a reactive dependency is first being accessed in the render function during render, meaning this dependency will now be tracked for changes. This hook can be helpful when we want to see which dependencies are being tracked for debugging purposes. Also, there's onRenderedTriggered. This is called when a new render is triggered, allowing you to inspect which dependency triggered a component to re-render. As you can imagine, this is going to make debugging a lot easier when we need to figure out which dependencies are being tracked and which dependencies are triggering our component to re-render. Also could be good when we're doing performance optimization. I'm really excited to see what sort of optimization tools can be created centering around these hooks. Our next Vue 3 syntax is best taught by looking at a code example. So here you can see we have a template with a search input box. And when we search, we want it to return the number of event results. Inside the script tag, we need to import ref, because we'll have some reactive references, and we'll import the event API. This is just a dummy API I threw together for the example. Then inside of our setup method, we have our search input and our results for our reactive references. Remember, we're just returning the number of results, not the actual results. Then we'll call our event API, sending in the search input value and returning the results. And then finally, since we need these inside of our template, we'll return both search input and results reactive references. Now, if we jump in our browser, we'll see that this doesn't work yet. Not at all. The problem is that with our current code, our API call only gets called once when setup is initially run. And we need it to run every time the search input changes. This is where we need to use the watch effect syntax, which is new for Vue 3. We'll import it, and we'll wrap our code in a callback.
Watch effect will run this function on next tick while reactively tracking its dependencies and rerunning it when its dependencies change. So if we look in our browser now, as we type, our number of events gets updated. You can think of watch effect as a simpler version of the watch function that you might be familiar with from View 2. We still use the watch function when we want to be specific about what triggers the watcher to run. So even if our callback includes other reactive objects, it won't get called unless search input changes. Using watch, we can also get access to the new value and old value of the item being watched, like you see here. We can watch multiple reactive objects by sending in an array, and we can also get access to the new and old values of each of these if we need them in our callback function. So what might it look like if we use watch instead of watch effect in our example? First, we import it. Then we'll call watch search input because we want to run the callback when search input changes. If we looked at this in the browser, we would notice number of events starts out as empty, and then it works as we type. It started out as empty because it didn't get run on initial load. In other words, watch is lazy loaded by default. This might be the functionality you want. However, if you did want to use watch and have it run on initial load, then you can send in the option immediate true. This will run the code immediately and then again when search input changes. So as you can see here, number of events starts at 0 because it ran initially, and then it works as we expect. So watch effect only ever takes a single argument, which is the callback, and watch has multiple arguments, including the reactive object we want to watch, and options if we want to configure it.
In this lesson, we're going to be looking at solving a problem using the composition API. When we have two components that each do API calls, there's a bunch of extra code that usually you need to write around these API calls, which usually are promises, because you need to check for when it's loading or not loading or done loading, and if there's any errors that pop up. So usually what you end up doing in your code is creating another file that encapsulates this behavior. In our case, we'll be moving some of that shared code into a file called usePromise in our composables directory. This will be more clear in our code example, so let's dive into it. Here we have a single component which has a search input, and for now we're just printing out the loading status, the error status, and the number of events that match this search input. Notice we're not actually returning the results, just the number of results. In the browser, this is what this template is going to look like. Further down in the file, we can see that we're importing using our composition API. So we're in View 2 using the composition API plugin. We're also using this dummy event API file, which we don't need to read. Then we have inside of our setup method our reactive references for our search input, our results, our loading, and our error state. And they each have an initial value. Next, we have our load data asynchronous function, which is called whenever our search input changes. First, we set loading to true. We reset the error and results values. Then we do our API call, and on return, we set the result value. Any errors are caught, and then finally, we set loading value equal to false. Now we have a little bit of code to write. We want to watch our search input, and when it changes, first we check to see if our value is not empty. If it's not empty, we'll go ahead and call load data with our search input value. Otherwise, if our search input is empty, we'll set the results to null. And lastly, we need to return the items that our template needs access to. If we jump into the browser, we can see that as we type into the search field, loading gets toggled and the number of events gets returned. This works great, but let's modularize the code around our API call so that we can reuse this in other components. To do this, first, I'm going to copy some of the code in our component. Then I'm going to delete this code except for the API call, which is specific to this component. Then I'm going to jump into the usePromise.js file, which I just created. Inside the file, I'm going to import from the composition API. And then I'll create a function called usePromise, which receives the function to call with async_await, basically our API call. I pasted our code here, but it needs some modifications. First, we're going to create a constant called createPromise, which will contain an asynchronous anonymous function, which receives any arguments that our API call needs. Then, instead of doing the API call here, this is where we call the function we passed in earlier with the arguments we send in. In our case, we'll have a single argument, which is the value of the search input. Lastly, we'll return results, loading, error, as well as our createPromise function. Now, back inside of our app.view, we can import the usePromise function. Then we'll create a new constant called getEvents, which calls usePromise. It has a single parameter, which is search. Then we'll execute the API call specific to this component to get our event count, sending in our search value. Then inside of watch, now when the search input changes, we need to call getEvents.createPromise, sending in our search input. Our results are now inside getEvents if we need to reset them. And lastly, results, error, and loading can be destructured from the getEvents object. Now, if I jump into the browser, I can see that everything is still working, except now my code is more reusable. When I showed this code to two different members of the Vue core team, they wanted me to make a change. They basically said, hey, you should keep the return values namespaced under the object getEvents. Don't destructure it. If I did this, the code would change to look like this, where I have getEvents.getEvents.getEvents. Now the data is a little more encapsulated and it's clear where it's coming from. However, if we look in the browser, we can see that it's not working. Vue isn't recognizing that these are reactive references and calling .value on them. To fix this, in Vue 2, using the composition API, we could just call .value on each of those items in the template. And that would be the solution here. However, I did want to validate if this worked or didn't work in Vue 3. So I fired up some code in Vue 3, and sure enough, this code would work as expected with Vue 3. You wouldn't have to call .value. It would recognize them as reactive references. So it seems to be a bug in the composition API plugin for Vue 2. It's pretty common that our Vue applications make API calls. And when they do, it's a best practice to let our users know that something is loading, especially if it might take a little while to return from the API call. Then once it returns, we display the template onto the page. The simplest way to implement this